This class answers one fundamental question: what are the raw data types Java provides, and how do you work with them mathematically? We start with the 8 primitives: byte, short, int, long, float, double, char, and boolean, each with its size, default, and intended use. You'll notice that every wrapper class, like integer for int, supports automatic boxing and unboxing, which becomes vital when you store primitives in collections. Typecasting follows. Widening conversions happen implicitly, but narrowing conversions require an explicit cast because you risk losing information. The arithmetic operators behave exactly as you'd expect, except for integer division, which discards the remainder and catches many beginners off guard. Relational and logical operators introduce short-circuit evaluation, and, letting you write safe null checks in a single line. We then touch on bitwise and shift operators for low-level scenarios and wrap up with the ternary operator for one-line conditions, alongside formatted output using printf and the built-in constant math.py. ControlFlow determines the order in which your code actually executes, and this class covers every tool Java gives you. First we have if-else chains. The order of conditions matters because evaluation stops at the first match. The classic switch statement is shown with its required break statements, contrasted against the modern arrow-style switch expression that eliminates fallthrough and can directly return a value. Loops come next: while checks its condition first, do while guarantees at least one iteration, and the classic for loop packages initialization, condition, and update into one compact line. The enhanced for each loop provides a cleaner syntax when you don't need the index. We then use break to exit a loop early and continue to skip an iteration, finally solving the nested loop exit problem elegantly with a labeled break, which breaks out of a specific outer loop without extra Boolean flags. Strings are the most used type in real applications, but they have subtleties that trip up even experienced developers. You can create them with literals, which go into a reusable string pool, the new keyword, avoid it, string.format, or modern text blocks for multiline clarity. Because strings are immutable, every method, trim, strip, to uppercase, substring, returns a brand new string, prefers strip over trim since it handles all Unicode whitespace. Splitting and joining is straightforward, but remember that split interprets its argument as a regular expression, which can surprise you with characters like. The single most important lesson: never compare strings with equals equals, it compares memory addresses, not content. Always use .equals. Finally, when you need to build a long string in a loop, replace repeated concatenation with string builder, which uses a mutable internal buffer to avoid creating mountains of garbage objects. Arrays are Java's simplest collection, a fixed size, contiguous block of items of the same type. You can initialize them with curly brace values or allocate with new, knowing that numeric slots default to 0, booleans to false, and objects to null. Once created, an array's length cannot change. For resizable storage you'll eventually turn to ArrayList. The java.util arrays utility class shines here. Sort rearranges elements in place, binary search finds a value lightning fast, provided the array is first sorted, fill stamps a value across all slots, and copy of range produce new arrays of any desired length. Two-dimensional arrays are technically arrays of array references, which enables jagged arrays, rows of different lengths. We preview the stream integration with arrays.stream, letting you call operations like sum, average, or max directly, tying arrays smoothly into Java's functional capabilities. Before we wrap up, an important reminder: none of this code compiles yet. It can't. It's a collection of standalone demo methods designed to be called from main.java, and we won't wire everything together until the final chapter of this series. For now, treat what you've just seen as pure reference material. If something feels fuzzy, pause, rewind, and watch it again until it sticks. There is no shame in repetition, there is only the cost of moving forward with gaps in your foundation. Take notes. Better yet, type every line yourself. Muscle memory is real, and the act of typing, of making mistakes and fixing them, burns these patterns into your brain far deeper than passive watching ever will. In the next chapter, we'll build the package, encapsulation, inheritance, polymorphism, and abstraction, each with its own runnable demo class. That is where the architecture truly begins. Thank you for sticking through the fundamentals. Most people skip them. You didn't. That already puts you ahead. I'll see you in the next episode.